YouTube channel. In today's video lesson, I am going to be teaching you words sound wave. I'm going to be teaching you sound wave. Remember that there are two basic types of wave. We have the electromagnetic wave and we have the mechanical wave. Okay, now sound wave happens to be what an example of your mechanical wave. Now, if you want to go into this in details, I would like for you to take your book and your pen and jot this down. Remember, we have mechanical waves. Mechanical waves. What did we say is mechanical wave? Mechanical wave are those waves that requires material words medium for their propagation and transmission. Now, remember there are some waves that can be propagated without a medium. They can move from one point to another without a material medium conveying it. Okay, that wave is called electromagnetic wave. But mechanical wave are those waves that requires material medium before they can be transferred from one point to another. So take note of that mechanical waves are those waves that requires material medium for their propagation or transmission. And if I'm to give you an example of a mechanical wave or a type of mechanical wave, I would say sound wave. Sound wave. Sound wave is an example of mechanical wave. Another example of mechanical wave is your water wave. Okay, then we can have wave in a pipe, whether a closed pipe or open pipe, and then we have wave in a string. All of these are examples of mechanical wave. But in today's video lesson, our focus is going to be on sound wave. So, what is sound wave? Sound wave is an example or a type of mechanical waves that requires material medium for their propagation. So take note of that sound wave is associated with your word mechanical wave. Take note of that. And what did I say is mechanical wave again? They are waves that requires material words medium for their propagation or transmission. So take note that sound wave requires material words medium. It is not like light wave that can move from one point to another without a medium conveying it. Sound gradually dies when there is no medium to convey it. So sound can pass through solid. Sound can pass through what? Liquid. Then it can also pass through gases. Okay, you see that you put gases or you put you put air. So these are the medium by which sound can be propagated. The speed of sound in a solid material like your glass is around 5,000 meters per second. The speed of sound in liquid like water is around 1,500 meters per second. The speed of sound in gases is around 330 to 340 meters per second, depending on the temperature of the gas. So take note that sound wave, unlike electromagnetic wave, can be propagated through solid material. It can be propagated through liquid material and even through gases. Again, you see that sound travels fastest in solid than in liquid, and it moves faster in liquid than in gas. That is to say that the material to which sound wave travels fastest is solid. So if I give you a simple question like this, which of the following material will sound wave have the greatest speed? Which of the following material will sound wave have the greatest speed? A. Water. B. Steel. C. Air. D. Hydrogen. Which of the following will sound wave have the greatest speed? What is the answer to this question? Wow, it is very easy. Don't forget that water is a liquid state of matter. Don't forget that steel is a solid state of matter. L is a gaseous state of matter. and hydrogen is gaseous state of matter. So if you are given this four options, you see that the answer to this question is not A, it is what? It is B. Why? Because sound have the fastest speed in words in solid. Is that clear? So sound wave is a type of your word mechanical wave. Now let us be conservative with our time. Let us go to what we call the speed, factors affecting the speed of sound in air. Factors affecting the speed of sound in air. Factors affecting the speed of sound in air. Now, there are various factors that either increases the speed of sound or reduces the speed of sound in air. I want you to take your book and your pen and jot this down. This must be noted. Number one factor is called your temperature. Yes, is your temperature. And I want you to note that the temperature should be in Kelvin. So temperature in Kelvin. Temperature in Kelvin, and that is T. Please, what is the relationship between the speed of sound and temperature? Now, the higher the temperature, the faster the speed or the greater the speed. That is to say that the speed of sound is directly proportional to the square root of your what now? Temperature. So, if your temperature increases, you will see that the speed will also what? Increase. Take note of that. If your temperature increases, so it means that hot gases, sound travels faster in hot gases than in cold gases. So in hot weather, the speed of sound is faster than in cold weather. Why? The temperature of sound of air in hot weather is higher than the temperature of air in cold weather. So if I have hot weather and I have cold weather, in which of the following medium will the speed of sound be greater? It is the hot weather. Why? The increase in temperature increases the speed of sound. And if we combine this together, you see that we have V equals to K times the square root of T. Follow me carefully. Therefore, you know that your K will be weighting now, will be constant. And if you make your K subject formula, you have K equals to V over the square root of T. Don't forget this is speed and this is temperature. So therefore, you have V1 over the square root of T1 equals to V2 over the square root of weighting T2. This is the first speed, this is the first temperature, this is the second speed, and this is the word second temperature. So that's number one factor affecting the speed of sound in air. Now let's consider the second factor, which we call density. Number two, this must be noted. Density. Density has a symbol like P. It's not P. This symbol is a symbol of density. It's pronounced as R-O-H-O. You can call it rho. This is a symbol for density. Now, what's the relationship between the speed of sound and density? Don't forget that the higher the temperature of a medium, the lower the word, the density, isn't it? So it means that temperature and density are inversely proportional to each other. For instance, if you put water in a pot and you heat it, as the temperature increases, the density of the water reduces, okay? It reduces, except you are looking at the anomalous behavior of water, okay? For all liquid in general, if I have oil and I put it in pot and I heat it, the density reduces as the temperature increases. So that is to say that density and temperature are inversely proportional to each other. So therefore, if the speed of sound is directly proportional to temperature, it means that the speed of sound will be inversely proportional to weighting the square root of your word, your density. Take note of that. So it means that if your density increases, the speed of sound will do weighting will reduce. Yeah, it will reduce. Why will it reduce? Because at higher density, the the molecules becomes compacted together. Okay, so if you increase density, the speed reduces because they are inversely proportional to each other. Don't forget, I said, note this, that temperature is inversely proportional to density. So the higher the temperature of the molecules, the lower the word density. Good. Number 3 factors that affect the speed of sound in air is what we call relative humidity. Relative humidity, which is ROH. Please, what does relative humidity means? Remember that relative humidity is the measure of the word, the amount of water vapor present in the world, in the atmosphere, the measure of the amount. So don't forget that sound wave is a mechanical wave. So the more the molecules in a medium, the greater the speed. So if the water vapor in the air increases, it means that we have many molecules in air, and that will further increase the speed of sound. The more the molecules, the more the medium, the greater the speed. So therefore, the speed of sound is directly proportional to relative humidity. That's good. Number 4, we have what we call wind direction. Wind direction. Please, this must be noted. This must be noted. The 4th factor affecting the speed of sound is wind direction. Now, if the sound is going in the direction of the wind, then the speed will increase because the wind will transfer the sound. It will increase the speed of the sound. Look at what I'm saying. If this is the direction of your sound, if the sound is moving from point A to B, if it's moving from point A to point B, if this is the direction of the sound, and then your wind is also going in the same direction from A to B, if this is the direction of your wind, now, since the wind and the sound are moving in the same direction, what does that simply mean? It means that the speed will increase. Yes, it will increase. Because why? The wind and the sound are moving in the same direction. So if the wind will propagate the transmission of the sound. In the other way around, if it moves from A to B, if the sound moves from A to B, if the sound from A to B, and the wind moves from B to A, you see now, did you see that the wind is going against the direction of the word of the sound? So because of that, your speed will reduce. Speed will reduce. This must be noted. Please take note of that. It must be noted. The last factor affecting the speed of sound is the moduli of elasticity of the medium. Number 5 factor is moduli of elasticity of the medium. This must be noted. So let us use the letter, please, E. Don't forget that we have 3 moduli of elasticity. I told you during JAM class that the moduli of elasticity are 3 numbers. We have the moduli for solid, it's called Young's modulus. We have the moduli for liquid, it's called Bock modulus. And we have the moduli for gases, it's called what? Shear modulus. So we have Young's modulus. Look at it. For solid, the moduli is called Young's modulus. Take note of that. Modulus. And the symbol is Y. Okay? Now, for liquid, the moduli is called Bock modulus. So, you can use the letter K. Okay? For gases, the moduli is called shear modulus. It is usually ratio of your specific heats to your pressure. Yeah, this is what we have. This guy is called ratio of specific heat, while this is pressure. This is where pressure comes into play in determining the speed of sound. Okay, is that clear? So take note. So it means that this modulus of elasticity can be studied under three headings. One, it can be for solid, it can be for liquid, and it can be for gas. For solid, it's called Young's modulus. For liquid, it's called bulk modulus. For gases, it's called what? Shear modulus. Please, this must be noted. Now, I'm going to give you the formula for the speed of sound as it relates to this factor affecting the speed. Now, for number one, Young modulus, for solid, speed of sound is equals to, please take note of this, the speed of sound is equals to the square root of your Young modulus over density. Take note of that. This must be noted. For solid, the speed of sound is Young modulus over density. I told you symbol means Young modulus, okay? That's number one. Number two, for liquid, the speed of sound is equals to what? Your bulk modulus K over density. Wow, that's interesting. Take note of that. Finally, for gas 6, the speed of sound is equals to the square root of what? I told you this is called ratio of specific heat. Why this is called your word? Pressure. So you have ratio of specific heat times pressure over density. This must be noted. Now let's quickly do this. Let's do this quickly. Okay? Now we have that. Remember what I told you? This guy is called ratio of specific heat. It must be noted. This guy, P, is your pressure. Remember, your pressure can be in Newton per meter square or can be in word, Pascal. This must be noted. Now, from what we have seen so far, we have 5 major factors affecting the speed of sound. Is that clear? And you are seeing how these values affect the speed of sound. For this, in general, still under your modulus of elasticity, we can say that because if you watch very well, you will see that speed is directly proportional to Young modulus. Speed directly proportional to bulk modulus. And it's also developed with shear modulus. Is that clear? So we can say that in general, the speed of sound is directly proportional to the square root of what? Elasticity of the medium. So this is the general word formula. And here you must note this, that pressure as a single word, variable or parameter, as a single parameter cannot determine or do what? Affect waiting now the speed of sound. So this must be word noted. Pressure as a single entity cannot affect the speed of sound. So note this. Now we are going to take just few questions on this. Now we are going to solve this question. We have question number 1, 2, 3, and 4. I'm going to treat these 3 questions, and in our next video lesson, we are going to treat this. But I'm going to give you this as an assignment to solve, okay? Make sure you solve it and send me your answers in the comment section. If today is your first time for coming across my YouTube channel, if you are a student preparing for WAEC, GC, NECO, JAM, or post-UME, this is the best channel you can link up to. In this channel, you are going to be learning mathematics, physics, and chemistry. Okay? So please do well to like our videos. Also share to your friends. If you haven't subscribed, subscribe to our channel so that whenever we post video, you'll be notified. Now, let us solve this simple question. Question number 1 says what? Which of the following factors affect the speed of sound in air? Roman figure I says temperature. Roman figure II says pressure. And Roman figure III says what? Frequency. Remember the video lesson we just did. I gave you the 5 factors that affect the speed of sound, which are temperature, number 2, density, number 3, relative humidity, number 4, wind direction, number 5, elasticity of the medium. But if you watch very well, you will see that I told you that pressure as a single entity cannot affect the speed of sound. So we have to root that out. Same for frequency. Frequency does not affect the speed of sound, so it's rooted out. The only factor that affects the speed of sound here is your word, temperature. Now let's quickly go to the option to see our answer. A says Roman figure I only. This is the answer to the question. It is not this, it is not this, it is not this. Be careful. Okay? In case you don't understand, go back to the video. Now, which of the following allows what? Transmission of sound wave through them. Don't forget that sound wave is a mechanical wave. Okay, mechanical wave are wave that requires material medium, unlike your electromagnetic wave. And I told you that sound can travel through solid, liquid, and what? Gases. So let's see this question. They said which of the following allows the transmission of sound wave through them? They gave us air. Air is a state of matter called gas. They gave us liquid. They gave us solid. So I think it can travel through air, it can travel through liquid and through what? Solid. So remember if you go I, and I only. So the answer is not A, it's not B, it is not C. The answer is what? D. It is D that satisfies the factors. Now let's take this question. Let's take question number 3. Now, according to question number 3, don't forget that this one is for you. You are going to solve it. Now, the velocity of sound in air of 16 degrees Celsius. Remember I told you that your temperature should be in Kelvin. Take note of that. Now, is this. So we can say that your first speed, V1, is what? 340 meters per second. Is that clear? Good. Then what's the first temperature? It is what? 16 degrees Celsius. Look at it. 16 degrees Celsius, and this is the speed. Remember, you must convert to Kelvin. So you have plus 273. So what would that give us? If you have 273 and then you have 16. So here you have 9, here you have 8, and here you have 2. So you have 289 Kelvin. This is the temperature, T1. Now, what will it be if the pressure is double? Don't forget that pressure has no effect on the speed of sound. So we wrote that out, cancel it out. And its temperature is missed toward 127 degrees Celsius. So what will the speed be? V2 is unknown. If the temperature T2 becomes 127 degrees Celsius. If you have 127 degrees Celsius, you add 273. Let's do that quickly. 273, 127. So you have 0 carry 1. 7 plus 2 is 9 plus 1, 10. 0 carry 1. And then you have 400. Okay? Now, so the temperature, which is T2, is 400 what now? Kelvin. Remember the factor affecting the speed of sound says what? That V is direct proportional to the square root of T. From here, we got a formula V1 over the square root of T1 equals to V2 over the square root of T2. Don't forget this. We did this. That was the first factor affecting the speed of sound. Okay, so let's do this quickly. What's V1? V1 is 340. What's T1? We have the square root of 289. Okay, then equals to V2. We don't know what V2 is. Over what? The square root of 400. How do we solve this? This is 340. What's the square root of 289? The square root of 289 is around 17. Yeah, 17 equals to V2. The square root of 400 is what? 20. So what do we simply do? We cross multiply. You know, if you are a JAM student or YX student or POSIM student, you don't have to bother yourself to cross multiply here again because you now have to divide both sides by 17. So just cut it short. Use to times this, so you have V2 is equals to 340 times 20 over weighting at 17. So V2 will give us what? 340 times 20 over 17. I think this will cancel this to give you 20. 20 times 20 will give us 400 meters per second. So let's check. Okay, the answer is not A, the answer is what? B. It is not C, it is not D. Thank you very much. We have come to the end of today's video lesson. Please Make sure you send your answers to me in the comment section regarding this question. Don't forget that the speed is equals to your Young modulus over density. Don't forget that. Thank you very much. I'll see you in my next video lesson.